This is sections 9.1 and 9.2 of Honors Algebra 2, distance, midpoint, and circles. Let's just jump right in. Let's find the distance between -2, -1, and -4, 3. Alright, let's plot those 2 points. -2, -1 is down here. And -4, 3 is up here. I want to find the distance between them. That would be the length of this line segment. Well, how am I going to do that? Well, let's make a triangle. Oh, it happens to be a right triangle. Oh, hey, what's the length of this side of the triangle? Well, that's the distance from -2 to -4. What's that distance? Well, it's a distance of +2. What's the length of this side of the triangle? Well, that's the distance from -1 to 3. What's that distance? Hey, that's 4. So that means I know 2 sides of a right triangle. And what I want to know is the hypotenuse. How do I find that? The Pythagorean Theorem! You're so smart. Let's use the Pythagorean Theorem, okay? So our distance, d, is the length of the hypotenuse. So we got 2 squared plus 4 squared equals d squared, right? That means 4 plus 16 equals d squared. So 20 equals d squared. So what is d? Well, d is the square root of 20. That makes d 2 radical 5. Now, don't I need a plus or minus when I take the square root of both sides? Well, technically yes, but a distance is never going to be negative, so I'm just throwing out the negative answer. And all I really want is the positive answer. So I've got 2 square root of 5. Cool. It would be great then if I could generalize that into a formula. So let's do that. It's called the distance formula. The distance between the points x1, y1 and x2, y2 is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So the difference in the x's squared plus the difference in the y's squared. And really, that's what I just did in my example. I took the difference in the x's and I squared it in the Pythagorean Theorem, and the difference in the y's, and I squared it in the Pythagorean Theorem. I added those 2 numbers together and I took the square root. That's the distance formula. It's proven by the Pythagorean Theorem. Cool. How about a midpoint? Find the midpoint of the line segment joining 4, -6, and -3, 2. Well, let's plot them. 4, -6, and -3, 2. I want to know the midpoint of the line segment that joins them. Well, how do I find that midpoint? Well, what if I make a triangle? If I were to find the midpoint of this side, which I can find by averaging my x-coordinates, 4 plus -3 divided by 2, so that would be 1 divided by 2, which would be 1/2. This has a midpoint of 1/2, and I find the midpoint of that side of the triangle, so that would be 2 plus -6 divided by 2. That's -4 divided by 2. That's -2. That is the midpoint of -2. Then I found the midpoint of the hypotenuse. 1/2, -2. So all I really did was I took the average of the x's, 4 plus -3, and divided it by 2. That's how I take the average. I add them up and divide by how many I have. And I took the average of the y's, -6 plus 2 divided by 2. And that gave me 1/2, -2. And that was the midpoint of the line segment. Hey, let's generalize that to a theorem. Okay, the midpoint formula. The midpoint of the line segment joining the points x1, y1 and x2, y2 is the point given by x1 plus x2 over 2, comma, y1 plus y2 over 2. So it is a point, an ordered pair, where the x-coordinate is the average of the 2 x-coordinates you have, and the y-coordinate is the average of the 2 y-coordinates you have. Awesome. Let's move on. Find an equation of the perpendicular bisector of the line segment from -2, 1 to 1, -3. So I want the equation of the perpendicular bisector. So it has to be perpendicular and it has to bisect it. if I want the equation of a line, I need to know two things about it. I need to know the slope, and I need to know a point. So let's find a point. Well, a point on that perpendicular bisector would be the midpoint, because if it's going to bisect it, it must go through the midpoint. So let's find the midpoint. And let's use the midpoint theorem. We average the x-coordinates, -2 plus 1 over 2. We average the y-coordinates, 1 plus -3 over 2. So my midpoint is -1 over 2, so -1/2, comma, -2 over 2, so -1, -1/2, comma, -1. That point must be on my line. Okay, well, I need to know the slope. So if it's going to be perpendicular to the line segment that contains those points, then it must have a slope that is the negative reciprocal. So let's find the slope of the line that contains those 2 points. All right, -3 minus 1 over 1 minus -2, which is plus 2. So that gives me -4 over 3. So the slope of the line that I want is going to be the negative reciprocal of -4 over 3. It means it's going to be positive 3 over 4. So I've got a slope of positive 3 over 4. I've got a slope, I've got a point. Let's find the equation. All right, well, I remember that y equals mx plus b, so y equals 3/4 x plus b. I need to find b. I'll use my point. I'll plug in -1 for y. I'll plug in -1/2 for x, and I'll solve for b. So what's 3/4 times -1/2? That's -3/8. So -1 equals -3/8 plus b. So b equals -1 plus 3/8. -1 is the same as -8 over 8. -8 over 8 plus 3 over 8 is -5 over 8. Okay, so my line could be written as y equals 3/4 x minus 5/8, but that's in slope-intercept form, and I prefer standard form. So we're going to put it in standard form. We're going to multiply everything by the common denominator of 8 and get 8y equals, well, when I multiply 3/4 by 8, the 4 cancels into the 8 2 times, and I've got 2 times 3, and that's 6, so 6/8 minus 5. I bring the x to the other side. I've got -6x plus 8y equals -5. Is that in standard form? No, because the first term must be positive. So I multiply everything by -1, and I get 6x minus 8y equals 5. And that's the equation of the perpendicular bisector of that line segment. Awesome. Let's move on. Imagine for yourself a right circular cone. Or just look at the page. Look at the screen, because I've imagined it for you. That is a double right circular cone. So the bottom half is a right circular cone, the top half is an inverted right circular cone. Right, because it stands upright, or if you were to draw this, it makes a right angle. Circular, because the base is a circle, and it's a cone. It goes up to a point. So I've got a double right circular cone. What we're going to do with this right circular cone is we're going to take a plane, which, remember, is a infinitely large, completely flat, two-dimensional surface, and I'm going to pass this plane through my right circular cone. Now you should note that this right circular cone is also infinite. It does not stop here and here. It keeps going forever and ever and ever. So it's an infinite surface as well. I'm going to take a plane and I'm going to pass it through there. And the different shapes that I can form when I do that are known as conic sections. So there are really 4 conic sections. These are the 4 possibilities. My planes here are in orange, and you'll see them passing through the gray right circular cones. So first, my plane could go diagonally in a way that is essentially parallel to that line in a way. So it's got to have the same angle as that line. If so, it forms a parabola. It could be the case that my plane is perfectly horizontal, parallel to the bases of this cone. And in that case, the cross section it forms with the cone is a circle. If I just tilt the plane a little bit, but not so far that it's at the same angle as that parabola was, if I just tilt it a little bit, I get an elongated circular-like shape, but it's not actually a circle. It's called an ellipse, or an oval in layman's terms, but mathematically it's an ellipse. If, say, my plane was at such an angle that it will ultimately pass through both the top and the bottom halves of my right circular cone, then I've got what's called a hyperbola when I take the cross sections. A hyperbola has two pieces. It's got this top piece and this bottom piece. So we're going to be spending this whole chapter exploring these four conic sections: parabola, circle, ellipse, and hyperbola. Today, we'll just look at the easiest one, a circle. Let's define a circle. A circle is the set of all points in a plane that are a fixed distance, called the radius, from a fixed point that we call the center. So a circle is defined by a radius and a center. It's got a point, and it's all the points that have the same distance away from that given point. So let's take this example here. My center is at 2, -3. My radius is 6, so I've taken all the points that are exactly a distance of 6 units away from my center. So there's one that's marked there as P, but here's another one that's also 6 units away from the center. And I could take that and I could trace all the way around the circle, and every point on that circle is exactly 6 units away from the center. Notice the circle only consists of those exterior points. It does not consist of everything on the inside. So the center is not actually a point on the circle. A circle is just those points that are exactly 6 from the center. Center is just a point that's helpful in determining what the circle is, or essential. Not only helpful, essential. What is the equation of a circle? If it can be graphed, it must have an equation, and that's true. Let's find the equation. Hey, why don't we use the distance formula? Because I know that a point xy is on the circle if and only if the distance between the point and the center is exactly the radius. So I want the distance to be exactly 6, the distance from that point xy to the center. Well, the distance formula says my distance is going to be x minus 2, the difference in the x coordinates, squared, plus y minus -3, or y plus 3 squared. That distance has to be 6. Okay, because the distance between xy and 2, -3 has to be 6. What if I square both sides? Then I've got x minus 2 quantity squared plus y plus 3 quantity squared equals 36. And now I've got an equation for that circle, where x and y represent any point on the circle. They will all satisfy that equation. That's pretty cool. Notice my center is those numbers right there. If I just take the opposite sign from what's in the equation, and my radius is that number squared. So here's the general form of the equation of a circle. A circle with center h, k and radius r has the equation x minus h quantity squared plus y minus k quantity squared equals r squared. Notice I emphasize the minus. You're going to take the opposite sign from what the center's coordinates are. For example, find an equation of the circle with center -2, 5 and radius 3. Well, it's going to be x minus -2 squared plus y minus 5 squared equals 3 squared. So let's simplify that. X plus 2 quantity squared plus y minus 5 quantity squared equals 9. And you stop there. Do not multiply those things out. Do not FOIL them out. Stop right there. Easy, right? Cool. Graph. X minus 2 quantity squared plus y plus 6 quantity squared equals 4. Well, what's the center? Center is 2, -6. What's the radius? 2. It's the square root of 4. Alright, so I'm going to take 2, -6, put a dot there, label it 2, -6, and I'm going to go a distance of 2 away from that. In which directions? Every direction. The easiest points, though, are the ones directly above, directly below, directly to the left, and directly to the right. So I know, for instance, I can go straight up 2, and end up there at 2, -4. I can go straight down 2, and end up there at 2, -8. I can go straight to the right 2, and end up at 4, -6. I can go straight to the left 2 and end up at 0, -6. And then I can just sketch my circle from there, where every other point I'm drawing is also a distance of 2 away from the center. And I didn't do a very good job, but it's a circle, because I said so. Notice that this graph takes the equation x squared plus y squared equals 4 and shifts it to the right 2 and down 6. So x squared plus y squared equals 4 is an equation with a center of 0, 0 and a radius of 2. So if I take that circle, centered at 0, 0 with a radius of 2, and I shift it to the right 2 and down 6, I end up at the green circle, the one I just graphed. So in general, that's true. The graph of the equation x minus h quantity squared plus y minus k quantity squared equals r squared is the graph of x squared plus y squared equals r squared, shifted horizontally h units and vertically k units. This kind of movement, which we could term as a sliding or a shifting, is called a translation. So that doesn't change the shape, it just moves it. Just a helpful vocabulary word. Consider this equation, x squared plus y squared plus 10x minus 4y plus 21 equals 0. It's an equation, it has a graph. Is it a circle? It doesn't look like it. It doesn't look like the equation of my circle. Well, that's because I don't have it in the right form. So let's put it in the right form. Here's how. We're going to take that 21 and we're going to move it to the other side. So we'll have x squared plus y squared plus 10x minus 4y equals negative 21. And I'm going to group the x terms and the y terms. X squared plus 10x. I'm going to leave a little space, plus y squared minus 4y. I'll leave a little space, equals negative 21. What I'm going to do with those little spaces, and I'm going to fill them with the right numbers. The numbers that will allow me to complete the square with x and complete the square with y. So I'm going to complete the square with x and complete the square with y. I'm doing it twice, and we know how to complete the square. To complete the square with x, I'm going to take the 10, I'm going to divide it by 2 and square that. So that'll be 5 squared is 25. I'm going to add 25 to the left-hand side. In order to do that, I also have to add it to the right-hand side, or my equation is fundamentally changed, and I can't let that happen. Okay, I'm going to complete the square with y. I take negative 4, divide it by 2, that's negative 2, and I square it, that's positive 4. I'm going to add 4 to the left and add 4 to the right. Alright? That means I can factor each of those trinomials. Factor the x's, and I'll have x plus 5 quantity squared, because I completed the square, so I know it factors as a perfect square. And I factor the y's, and I'll have y minus 2 quantity squared. That equals, what's negative 21 plus 25? Well, that's positive 4 plus another 4 is 8. Hey, that looks like a circle. It is. This is a circle with center negative 5, 2, and radius square root of 8, which is 2 radical 2. So it is a circle. All I have to do is complete the square with x, complete the square with y. Let's find an equation of a circle with radius 3 that has its center in the first quadrant and is tangent to the y-axis at the point 0, 2. Tangent? What does that mean? And no, it's not sine, cosine, and tangent, though it's related to that. Tangent means the circle touches the line at exactly one point. So it's tangent at 0, 2. There's 0, 2. It's going to be tangent to that. It's going to be with its center in the first quadrant and a radius of 3. First quadrant is the top right corner, remember? Radius of 3. So I'm going to go 3 to the right of my point. That must be the center. I know it's to the right because I need to be in the first quadrant, and I know it's there because it has to be a distance of 3 away from the point that I know, which is 0, 2. Well, what's another point on this? Well, let's go down 3. 1, 2, 3. Let's go up 3. 1, 2, 3. Let's go to the right 3. 1, 2, 3. So here's my circle. Looks great, right? It's tangent to the y-axis at 0, 2 because it only touches the y-axis at that one point. So let's find the equation. Well, x minus 3 quantity squared plus y minus 2 quantity squared equals 9. Plug in the center, plug in the radius, you're done. Here are your immediate practice problems. 4 of them. Number 1, find the distance between 6, 2 and 0, negative 2. Apply the distance formula. Number 2, find the midpoint of the line segment containing 6, 2 and 0, negative 2. Apply the midpoint formula. Number 3, find an equation of the circle with center negative 1, 3 and radius 2. Plug them into the equation of a circle. Number 4, find the center and radius of the circle x squared plus y squared minus 6x plus 2y plus 6 equals 0. You're going to complete the square with x, complete the square with y. But first, move that 6 to the other side. That is the end of sections 9.1 and 9.2.